Loneliness is really dangerous. That condition where you can't see anyone for miles, there's no one to talk to, no one to help, and you're badly trapped by this situation. Just thinking about it is scary. What if suddenly every human disappeared from this earth? If only you were left behind, that loneliness would eat you up from the inside. And maybe in that eternal loneliness, you would even start talking to the silence. You would be alone in your house, in your city, in your country, and even on this earth plunging into this terrible darkness, you would be all alone. What scares us even more is that we still haven't found any neighbors in this universe, and we still feel this cosmic scale loneliness today. This whole scenario becomes even scarier when you realize that no matter what you do, you can't stop that impending loneliness. It will happen no matter what, and something like this is happening in our universe as well. Our universe is constantly disappearing, and even if we want to, we won't be able to reach the stars. Even if we travel at the speed of light, knowing all this, we still can't do anything. We can only watch as this universe renders us powerless, imposing limits like the speed of light on us for so many important tasks. How does this universe work? And perhaps we have been searching for this answer for centuries. So let's make a start today as well. If you want, you can close your eyes. Your imagination will make this video even better. It's been almost a century since we found out that our universe is expanding. By the way, the story behind the expanding universe is quite big, but we all know that Edwin Hubble proved this by studying the redshift of galaxies moving away, that in the universe we live in, things are moving away from each other. But they're moving away from us at an even greater speed. This was a frightening thought for all those who imagined a future human civilization that would rule over the entire universe. When there won't be any galaxies visible far out in the universe, will there be a dark sky, no stars to be seen? People make mistakes in understanding the theory of the expanding universe. Their argument is that if the universe is really expanding, if stars and galaxies are moving away from each other, then how can our neighboring galaxy Andromeda collide with us? So here we need to understand this theory, which says that this effect won't be seen in the objects in this universe, but in those parts of space where there is nothing for a long distance, the fabric of space expands, and that's where its effect can be seen. It's only been 20 years since this theory of the expansion of the universe was proven. But by then, a galaxy that we know will, after some time, move even farther away from us, and it will keep moving away from us even faster. And this will keep happening. Eventually, a time will come when it will move so far out of our reach that even thinking about reaching it will be impossible. We won't even be able to catch the light coming from there, and as it keeps expanding, we will never be able to see that galaxy again. And believe me, the universe is disappearing like this, and we can't do anything about it. When you look up at a star in the sky whose light took about 100 years to reach you, it means that star is 100 light years away, and the reason is that the speed of light has a limit. It can only travel the distance of 1 light year in 1 year. But when you are looking at the light coming from a galaxy which has traveled for about 100 million years to reach you, so it doesn't mean that the galaxy is 100 million light years away from us. Here, your calculation will turn out to be wrong. In reality, that galaxy galaxy will be much farther away than this. The reason is that when we talk about things on a small scale, they are often gravitationally bound. But when stars come together, it doesn't remain a matter of just a cluster scale. The light that travels from there to us takes a lot of time, and in the meantime, the expansion of space also does its work. The light that reaches us is also affected by the expansion of space. That means we call this cosmic redshift. If light is being emitted from somewhere because that galaxy is away from us, it has a particular energy and a particular wavelength, and we expect that when that light reaches us, it should have that same particular wavelength, and this would be possible if the universe were not expanding, but in reality, this never happens. The farther away a galaxy is, from this, we have learned that the universe is expanding and will continue to expand. But from this information, we can find out how the universe has evolved over time and what exactly the universe is made of. Scientists studied the light coming from distant regions of the universe. Based on their distance, redshift, their actual size and apparent size, their actual brightness and apparent brightness, the entire expansion history of the universe was recreated. And it was also found out what kind of energy and matter are present in this universe. This entire universe is made up of 68% dark energy, 27% dark matter, 4.9% normal matter, 0.1% neutrinos and antineutrinos, and about 0.008% photons. And when we came to know the components of this universe so precisely, the law of gravity was applied to them, and Einstein's general theory of relativity brought forth a dark chapter of this universe before us. First, these laws were applied to the dark energy-dominated universe, and the results we got were shocking. First of all, the galaxies that are not gravitationally bound to us will eventually disappear one by one. They will keep moving away from us faster and faster, and the space between them will keep expanding more and more rapidly. And this led us to a conclusion that is even more disturbing. This means that a time will come when, after reaching a particular distance because of the expansion of space, a photon that left our galaxy towards another galaxy or is coming from that galaxy towards our galaxy, it will never be able to reach us, nor will it be able to reach them. It will just keep running in the fabric of this infinitely expanding universe, keep running, but it will never be able to reach anywhere because space will be expanding at a speed much faster than that photon's speed. It's as if it's running on a treadmill, not even at 10 times the speed of light. But just think about it, if we set out on an intergalactic journey and got trapped in such an expanding space illusion, we would end up wandering there for eternity. We would neither be able to reach the galaxy ahead nor ever return home. This is nothing less than a nightmare. At that time, this space would seem no less than a black hole to you. The only difference is that here you would be able to struggle, you would get time to stay alive, but you would never be able to get out of here. If we talk about the present, the radius of our observable universe is about 46 billion light years, and that magical distance, meaning the reachable limit, is only 18 billion light years. You might be really shocked to hear that already 94% of the observable universe is out of our reach. Only 6% of the observable universe is such that if there's a galaxy at its edge, and if we set out to explore it today, we can actually reach it. And even then, we would have to travel at the speed of light, otherwise that too will disappear from this universe just like the rest. This means that every second about 20,000 to 60,000 stars are moving out of our reach. The light that left that star this second will reach us someday. But the light that leaves that star at the edge in the next second will never be able to reach us. This thing also seems scary to us. It's creepy, it's disturbing, and all sorts of strange thoughts start coming to mind. But we can also think about this in a positive way, that the universe wants to tell us that every single second of life is very, very precious. If we want to travel between galaxies, if we want to go beyond our local group, then we have very little time. Every single second, 60,000 stars are disappearing from our reach, places where maybe we could go. The more we delay, the more opportunities we will miss. There are about 2 trillion galaxies in the observable universe, and out of those, 94% have already moved out of our reach. Only 6% are left. Even that number is continuously decreasing. Another way to look at this is that no matter how big our universe is, only a small part of it, the observable universe, is available to us, which we can see and observe, and even then we can only reach 6% of it. So what's the use of such a universe where we can't even go? This raises a lot of questions in our minds. Are these limitations being set by the universe itself, or is there someone else stopping us from exploring this universe? And if we don't develop intergalactic travel soon, to get out of our local group, the entire human civilization will be confined to just our local group. The whole universe will slip out of its hands like sand, and all the other galaxies will slowly disappear from sight. A sky without stars will look completely dark, scary, and strange. Many questions come to mind. Sometimes you wonder why there's a speed of light limit, whether we can do anything about it, and whether we'll always be trapped like this. Let's look at the big theory. It took decades to reach here. It evolved from a single idea and came to be supported by extensive evidence and by physical and mathematical proof. This theory has come a long way. And during this journey, we found many things that, apart from the Big Bang Theory, it can't be proven by any other logic. And there are some things that directly or indirectly prove the Big Bang Theory itself. We are going to discuss all these things in detail in this video. So first, let me introduce you to the person who started all this, Eric J. Lerner. He is so desperate to prove the Big Bang Theory wrong that he has forgotten the difference between a theory and a hypothesis. And besides that, he is also quite frustrated with the entire scientific community that accepts the Big Bang Theory because that community doesn't give much attention to his illogical ideas. By the way, he has been speaking against the Big Bang for quite some time, but right now the mess that has been created, that is because of one of his articles which he published on the website of the Institute of Arts and Ideas. So let's see what the truth behind this claim is, and let's move on to this article. The headline is, "The Big Bang didn't happen. What do the James Webb images really show?" Below it, the date says July 11, 2022. Eric J. Lerner is obviously the writer of this article, and just take a look at this. President and chief scientist of LPP Fusion, he is the author of The Big Bang Never Happened. The
Big Bang never happened.
LPP Fusion is also a project by Eric J. Lerner in which he claims that he can make fusion reaction possible with a machine that can fit in a small storeroom, and the way he will carry out this reaction, there will be no nuclear waste. Today, big countries around the world are spending billions of dollars on technologies like tokamak for nuclear fusion. Meanwhile, Eric can complete the same fusion reaction for $9 million. By the way, whatever Eric says about the Big Bang, whatever his opinions are, but he is also a reputed scientist. He has written many papers. On top of that, he has even received funding from NASA for his work on plasma reaction. For his LPP project, if his claims about fusion technology are correct, then this is really a great contribution to science. But now you need to pay attention to the articles published on his website. 2 articles were published on July 5th. The first is Censored Papers Demolish the Big Bang Hypothesis, in which he has provided evidence to literally demolish the Big Bang Theory. Now you can tell how frustrated he is with the Big Bang Theory just by his wording. We'll also talk about why he called the Big Bang Theory the Big Bang Hypothesis. But the first thing to notice is that when Eric submitted his papers to archive.org, his papers were censored. And there's a specific reason behind this too. The points he presented to disprove the Big Bang Theory are the reason. He has already received refuttals from many scientists, meaning his points have already been proven wrong many times, but he's a bit stubborn. He just doesn't stop his actions, so this had to be done. However, we will also talk about what those points are. His second article on this website is Scientists Protest Censorship in Cosmology. Archive refused to publish research research papers of two of his colleagues along with him, which were questioning the validity of the Big Bang. So, in response to that, he gathered a total of 24 physicists and astronomers from 10 countries and signed an online protest, or you could say an online petition, against this step taken by Archive. Now, Eric is literally quoting wrong things just to prove the Big Bang theory wrong and is trying to create an atmosphere of confusion in the entire scientific community. So in this case, the step taken by archive.org also seems right, but they believe that this behavior is being shown towards them because they spoke against the Big Bang theory. Now, whether that's right or wrong, I'll leave that up to you, but before forming any opinion, do watch this video till the end. And all the references being mentioned here, you'll find the links to all of them in the description or in the pinned comment. Now, that was about their website. Now let's talk about the book published by them. Because look, whatever we're showing you here, these are very important things. These are quite interconnected and will help you a lot in reaching a final conclusion. Eric published a book in 1991 called The Big Bang Never Happened. The Big Bang Never Happened. Now just think for yourself, a person publishes a book called The Big Bang Never Happened. And when all over the world people start discussing that the Big Bang theory is succeeding day by day, so that person would obviously feel a bit frustrated, and maybe this frustration is what's coming out now. And it's possible that the success of the Big Bang theory has hurt his ego because he's against the Big Bang theory. If nature itself is presenting such strong evidence in front of someone making such strong claims, then maybe this gentleman may be panicking a little too much. And yes, one more thing, if there isn't any hype about Big Bang Never Happened, then the books he's written will become useless, right? And then how will they sell? So everyone needs hype, brother.
Alright, the crisis in cosmology is that if we go a bit further into this for the Big Bang, it's good.
So let's move forward in this article. Let's go a bit further, that it can't even differentiate between theory and hypothesis. So come on, let's first understand the difference between theory and hypothesis, because man, we don't want the next Eric to be one of us. And seriously bro, we also don't want any of your concepts to remain unclear. So it's written here. Now, a hypothesis is any guess or assumption that is made before conducting any research. Now, why do we make assumptions or guesses? So the answer is that we have to test or prove certain things. And apart from this, we use hypotheses to set some limits or to get a certain optimum range or result. Whereas a theory is something or a principle that proves what is visible in your data, a theory is based on conclusions drawn from observations and evidence. Now, the example for these is quite simple, and I know that you will really like this example. So you will hypothesize how much time this journey will take, what is the mileage of the bike, accordingly, how much will it cost, and apart from this, you will have to plan a lot more. First of all, you did some guesswork. This is the main part of hypothesis. Now you have come up with a certain result that it will take this much time and it will cost this much. So here, the results you have, you need to test them or prove them right. Now, why did you use a hypothesis? To set a certain limit, like if this journey can be completed in 20 to 25 liters, then there's no need to spend money on 100 liters of fuel. So we get this limit from the hypothesis itself, and this hypothesis will later become a theory. When you have data available to prove your assumptions and that data matches your assumptions or supports them. Suppose at that moment a friend of yours comes and says that he has done this journey before. So I hope you have understood the value and meaning of hypothesis and theory, but here, Mr. Eric should understand that CMB means cosmic microwave background radiation. It's just like that friend of yours who told you that the values you calculated are absolutely correct, meaning the values and results of the CMB. They can only be proven by the Big Bang, meaning it's an evidence that proves the Big Bang theory, which can only be explained by the Big Bang theory. So how can we consider the Big Bang to be just a hypothesis? Right now, we're not even discussing whether the Big Bang actually happened or not. First, let's at least agree that the Big Bang is a theory, not just an assumption, a guess, or a hypothesis. Besides, CMB is not the only evidence that supports the Big Bang theory. In fact, there are many things like the expanding universe, redshift, Hubble constant, dark energy, and many others that support the Big Bang theory. It has also been validated by numerous experiments and observations. January 1st, 1925 was the date when we humans made the greatest discovery about the universe. This was the date when the great cosmologist Sir Edwin Hubble revealed that the Milky Way is not the only galaxy in this universe. In fact, there are many more galaxies like it in existence, and the collective group of these galaxies forms our universe. This one theory shook the entire world of astronomy because after this, the expanding universe hypothesis and the Big Bang theory came into the picture. And before anyone realized it, the way humans looked at this universe completely changed. Now, beyond our own galaxy, we were able to consider objects from nearby galaxies and constellations as well. Meanwhile, when Sir Edwin Hubble noticed the patterns of distant galaxies, he found that the recessional velocity of these galaxies and their distance from our Earth are directly proportional. In simple words, the farther these galaxies are from us, the faster they are moving away. This rule of astronomy was named Hubble's law. Although at first glance, this law seems very simple and easy, but it holds within itself a very big mystery of this universe. Along with that, the Hubble constant obtained by solving this equation has also become a big headache for scientists. In such a situation, the question arises, what exactly is the Hubble telescope's observation trying to tell us about the stars in the universe? And what are we misunderstanding about our universe? Well, we will debunk all these myths of space science, so stay with us till the very end of this journey in today's episode, because by the end of this video, you will have encountered the secret gateway to the greatest mystery of this universe. So let's begin this journey. In the past, whenever scientists tried to determine Hubble's constant, they always ended up with a new puzzling number each time. This only made the puzzle even more complicated instead of solving it. That's why we still haven't been able to solve the greatest cosmological mystery so far. But efforts are still ongoing today. Even now, many astronomers and scientists are working hard to calculate it. So, setting all that aside, to get to the bottom of the matter, the first thing we need to know is what exactly this constant tells us. After all, what difference will it make if we find out the value of this Hubble constant? Let's find out. If we look closely at this equation, we'll find that there are two different entities here. The first is the recessional velocity of these galaxies, and the second entity is the distance between these galaxies. And this equation expresses the mathematical relation between these two entities. According to this equation, if we calculate the recessional velocity of galaxies in kilometers per second and the distance in megaparsecs, then the resulting value will come out in the unit of kilometers per second per megaparsec. To understand this better, suppose the value of the Hubble constant is 100 kilometers per second per megaparsec. That would mean that for every megaparsec of distance, a galaxy will acquire an additional recessional velocity of 100 kilometers per second. This also mathematically proves that as galaxies move farther away, their speed also increases. This same Hubble constant is denoted as h or h0 in the language of physics. In the world of cosmology, this number plays a very important role because through it, all forms of the universe from the Big Bang until now can be understood. This is the number that can provide us with solutions to all the mysteries related to the universe. So then, what is the problem that our scientists have failed every time in calculating it? And even today, almost 100 years after this discovery, this mystery remains unsolved. Well, the answer to this question is actually hidden within the question itself. Actually, to calculate the value of the Hubble constant, we need two things. First, the recessional velocity of that galaxy, meaning the speed at which that galaxy is moving forward in space, and second, the distance of that galaxy with respect to Earth. To calculate the recessional velocity of any galaxy, we observe the wavelength shift of the spectral waves coming from there, which is also known as the cosmological shift. Tracking this is very easy and simple, so there is no problem at this point. But the second parameter of this equation, distance, has always been a problem for us. There is a standard procedure to calculate the distance of any galaxy. Study their Cepheid variables. In simple terms, this is the method where the difference in light is related to mathematical time to determine the distance. This same process is used to measure the distance from almost every star or galaxy. In this process, the distances are determined based on the calculations of the luminous gaps of any body. When you look at the graph, at first the luminosity appears to decrease, then after a certain point it starts increasing again. Astronomers studied many parts of this universe and calculated observation values from there, which were then further compared with the visibility of those same objects from Earth. And after this equational study, finally that distance was found out, and after all these scientific observations and calculations, Sir Edwin Hubble calculated the value of the Hubble constant as 500 kilometers per second per megaparsec. To obtain this value, he found out the distances and recessional velocities of 46 different galaxies and equated them, after which he was able to reach this final conclusion by Edwin Hubble. The value that was calculated is 7 times higher than the value considered by modern science today. But the problem here is that we can use the Cepheid method only for objects that are within a distance of 1 kiloparsec to 50 megaparsecs, meaning this value will not be valid for galaxies beyond 50 megaparsecs, and we won't be able to observe them with this Hubble constant. If we need accurate information beyond that, then something even more precise is required, and that's where a new element enters this story. Type 1. A supernova is a binary system in which a gigantic white dwarf collides with a companion star and creates a hypercluster of energy. And in the end, when it explodes, it radiates extremely intense light rays, which help us further expand our understanding of universal distances. With the help of these explosion impacts, we are able to see much farther than 50 megaparsecs. To study these very supernovae, the Hubble Space Telescope will conduct the SHOES mission, which stands for supernova H0 for the equation of state of dark energy. Under this mission, these supernova explosions will be studied to create references, and by calculating gigantic distances through them, the Hubble constant will be determined. Recently, the Hubble SHOES report that came out in 2019 claimed the value of the Hubble constant to be 74 kilometers per second per megaparsec, whereas an elite team of scientists studying the universe rejected this report in their study and gave a different value. And this value was 67 to 68 kilometers per second per megaparsec, which was much lower than Hubble's value. However, Team Hubble did not give up here. After this, they observed Hubble's 10,000 orbits and around 10 supernova explosion track reports to obtain a new value, and this value was 73 plus or minus 1 kilometers per second per megaparsec, which was still much higher than the value measured by scientists, but this value also verified Hubble's 2019 calculations. Therefore, even today, there is still uncertainty about the value of the Hubble constant. We are still confused and doubtful about its actual value. By the way, what do you think? Will NASA's flagship telescope JWST be able to solve this mystery? Be sure to share your opinion with us in the comment section. We humans want to go to Mars, and plans for this are already prepared. If we want to land our astronauts on Mars, that is, on that planet, we need to study microorganisms in space. Yes, you heard it right, not our astronauts, but our tiny space travelers, microorganisms. Yes, that means those bacteria that already live in our orbital observatories and in space. We take them with us into space. Many of them are essential for humans. And some are very dangerous. But we still haven't understood how these bacteria react in microgravity and space, and the most dangerous thing is that we still don't know how many types of bacteria live on our International Space Station. But now NASA wants to find this out. Recently, astronauts have collected samples from almost every corner of the ISS. This is a way for us to find out if we can eliminate them or stop them. So far, nothing like a sci-fi movie has happened on the ISS, which is hundreds of kilometers above us. So how should we deal with bacteria during long-duration missions like going to Mars? Bacteria are always around us in many ways. They do. On our bodies and inside us, you can consider humans as a moving ecosystem because of them. Scientists believe that most of these bacteria are actually essential for us and they have a deep impact on our health. They affect our immunity, our heart, and even our mental health. Scientists often see this microbiome as an invisible organ that collectively works for our body. That's why it's no surprise that for long-term space flight missions like going to Mars or even farther, studying and understanding this invisible organ is extremely important. Scientists are not only concerned about the human microbiome, the spacecraft also has its own microbiome. In 1998, when the Russian space station Mir was deorbited into the Pacific Ocean, scientists found species of bacteria in its microbiome that we had never even imagined. They were hidden behind the service panel. At that time, scientists observed this microbiome working on the space station like a beautiful machine. Are scientists only concerned about the microbiome? You and your companions are going on a long journey to Neptune. And suddenly you find out that there is a bacterium on your spacecraft that eats the mass of the spacecraft, so how will you deal with this invisible enemy? And also, they are not biologists. In 2006, a team of scientists sent samples of Salmonella bacteria on the Space Shuttle Atlantis for 11 days, just to find out that when those bacteria are not much affected, and now that we have understood this space, during that time, these bacteria can weaken any space mission. Now when we It's crucial to fully understand and address them, which makes NASA's Jet Propulsion Laboratory even more important. In February 2024, astronaut Kate Rubins collected samples of bacteria from about 100 places on the ISS. They were kept in cold storage for a few months and then sent back to Earth. There, scientists will study their genetic signatures and name them, and a three-dimensional map of these microbes will be created. That means the entire microbiome of the ISS will be studied. It will be observed which types of bacteria can be found where. Scientists currently know very little about which molecules on the ISS are supporting the growth of bacteria there. This map can tell us which molecule is associated with which microbes and how it is helping to grow the microbial community. As soon as we know this, we can grow beneficial bacteria and reduce the growth of harmful bacteria, and that too just by controlling the amount of molecules or nutrients. With this, we will be able to find out about very long journeys. For example, the and which material should be used in the interior of the spacecraft for going to Mars. With this, we will be able to protect our spacecraft from getting contaminated before our astronauts do. Kasturi Banktesuran, who is a microbiologist at NASA JPL, says that right now we have to send samples back to Earth. These can also be studied on the ISS, but the process there will not be fast and we will have to deal with this hassle soon. Suppose that when we go to another planet, we won't have the option to send things back to Earth, nor will we have that much time. Because in any dangerous breakout, every moment is precious, and we have seen this very well during the COVID-19 pandemic. How can a tiny virus cause havoc all over the world? The samples that Rubin has collected include two types of samples. One sample is of microbes, while the other sample is of their metabolites, meaning the natural chemical byproducts of that microorganism. This will allow us to link the microbes with their metabolites. And when we have this data, we can make small biosensors that will be able to detect these metabolites. You can imagine a device that you can hold in your hand to detect the presence of bacteria or fungi on a spacecraft. It will be just like a carbon monoxide detector, although such detectors will become a reality in the next 10 to 15 years, allowing immediate action to be taken. By paying attention to cleanliness at specific locations, any outbreak can be prevented. This way, we will be able to make our future habitats safer. A lot of effort is put into keeping the population of these microbiomes under control on the space station. Every week, the ISS is thoroughly cleaned to prevent any such outbreak. Every astronaut on the ISS spends about 3 hours a week just on cleaning, which means that 6 astronauts spend around 18 hours every week cleaning the ISS. If you look at it, that's quite a lot, but the conditions on the ISS are completely different, where sanitization is extremely important. Because if you drop any kind of food on the space station, it doesn't fall to the floor like it does on Earth. It can go anywhere. It can stick to the ceiling, to the walls, meaning it can be anywhere. Meanwhile, some scientists believe that such a microbiome outbreak is not a major threat to us on a long interstellar mission or a Mars mission. Their argument is that we've been living on the ISS for the past 2 decades, but we've never seen anything like that happen there so far. Finding a dangerous bacteria is not necessarily a warning sign. We should only be worried if that bacteria starts making astronauts sick. We shouldn't end up killing the good bacteria around us out of fear of an outbreak. That's why this decision should be made very carefully. We should observe how different bacteria react in a stressful environment and make decisions based on that. At the same time, some scientists are also concerned about the damage these bacteria could cause to astronauts and spaceships. There is also concern that these bacteria might go to another world and end up destroying it. Another world means that when our astronauts travel to other planets, Earth's bacteria will also travel there with them. So there's always a fear that those bacteria might contaminate that planet. This could give us false positive signs of life on other places, and that's why NASA and other space agencies take a serious approach on this matter. That's why NASA crashed its Cassini-Huygens spacecraft into Saturn so that no contamination could reach its moons, where there is still a strong possibility of life existing. Anyway, the thing is, our astronauts themselves act like pathogens for other planets. The astronauts who will set foot on Mars for the first time, they will have their own unique microbiome, and the spacesuit they wear will also have its own microbiome. If organic maps that microbiome, they will be able to choose a better material for that suit and also clean it more effectively. Apart from this, organic can also design a better spacesuit from which fewer microbes leak onto another planet. Apart from this, the benefits of studying this subject don't end here. Even though this research is happening in space, its applications range from space travel to Mars colonization, but also here on Earth. Every place, whether it's our homes, airplanes, or hospitals, has its own microbiome. If we can stop some microbes from growing in space, we can do the same thing here on Earth as well. For example, there's a test going on regarding the efficiency of an antimicrobial coating on the ISS, which was made by Boeing. The idea is that if this coating can work in space, which is much more dangerous than Earth, then it will easily work on Earth as well. Often, space technology makes our everyday lives even easier. But for now, by understanding these bacteria, we can take our space travel to the next level. Loneliness is truly dangerous. That condition where you can't see anyone for miles, there's no one to talk to, no one to help you, and you're completely trapped by the situation. Just thinking about it is scary, that if suddenly from this earth, in that loneliness of time, you would be alone on this earth even in the silence. This thought scares us even more, that till now we haven't found any neighbor in this universe. And we still feel this loneliness on a cosmic scale even today. This whole scenario becomes even scarier then, when you realize that no matter what you do, you can't stop that coming loneliness. It will happen no matter what, and something like this is happening in our universe. Our universe is constantly disappearing, and with every moment, we are becoming more alone in this infinite universe. And in the future, there will be a moment when, even if we want to, we won't be able to reach even the nearest star. Even if we travel at the speed of light, we still won't be able to do anything about it, even after knowing all this. We can only watch as this universe makes us powerless, imposing countless natural laws like the speed of light on us, making us alone. Today's video will tell the story of our universe for billions of years to come. And in my opinion, this video goes beyond our present time. It's just to forget everything and bring some deep thoughts to your mind. It's to understand how this universe actually works, and maybe this is a question we've been searching for centuries. So let's begin today as well. You can close your eyes if you want. Your imagination will make this video even better. It's been almost a century since we found out that our universe is expanding. By the way, the story behind the expanding universe is quite big, but we all know that Edwin Hubble's observation of the redshift of receding galaxies was not limited to just that. In fact, the real point was that the farther a galaxy is from us, the faster it is moving away from us. This was a frightening thought for all those who realized that in the future, the sky would appear dark and no stars would be visible in the sky. So where would that advanced civilization rule? And this very question was frightening everyone. Many times people make mistakes in understanding this theory of the expanding universe. Their argument is that if the universe is really expanding and stars and galaxies are moving away from each other, then how can our neighboring galaxy Andromeda collide with us? So here we need to understand this theory, which says that galaxies are not physically moving away from each other, but rather the space between the galaxies is expanding. The objects in this universe that are gravitationally bound won't be affected by this, but in those regions of space where there is nothing for a long distance, the fabric of space expands due to the expansion of the universe, so its effect is seen there. The ones that are moving away from us today will keep getting farther from us over time, and because of that, they will move away from us even faster. And this will keep happening. In the end, a time will come when they will go so far beyond our reach that not only will it be impossible to reach them, but even receiving anything from there will be out of the question. We won't even be able to catch its light, and that galaxy will disappear from our view in this infinite universe. The space between that galaxy and our galaxy will start expanding faster than the speed of light, which is possible. Because of this, we will never be able to see that galaxy again. Light reaches you. If it took about 100 years to reach us, it means that star is 100 light years away. And the reason is that there is a limit on the speed of light. If it travels the distance of 1 light year in 1 year, it means that galaxy is 100 million light years away from us. Here, when you look at a galaxy, actually that galaxy will be much farther than this. The reason is that when we talk about smaller scales, things are often gravitationally bound. Stars come together to form clusters, and billions of stars come together to form a galaxy. Meanwhile, the expansion of space also does its work. The light that travels to us is also affected by the expansion of space. That means, along with space, the wavelength of light also gets stretched. And the more time that light takes to reach us, in that much time, the galaxy moves even farther away from us. Because that galaxy is not gravitationally bound to us, we call this the cosmic redshift. If light is being emitted from somewhere, it has a particular energy and a particular wavelength, and we expect that when that light reaches us, it should have that same particular wavelength, and this would be possible if the universe were not expanding. But in reality, that never happens. The farther a galaxy is, the more red-shifted the light coming from it appears to us. Now we know that the universe is expanding and will continue to expand. But with this information, we can find out how the universe has evolved over time and what exactly the universe is made of. Scientists studied the light coming from distant regions of the universe, their distance, redshift, their actual size and apparent size, their actual brightness and apparent brightness, and based on all this, they recreated the entire expansion history of the universe and also found out what kinds of energy and matter are present in this universe. 68% dark energy, 27% dark matter, 4.9% normal matter, 0.1% neutrinos and antineutrinos, and about 0.008% photons make up the entire universe. And when we found out the components of this universe so precisely, the law of gravity was applied to them, and Einstein's general theory of relativity revealed a dark chapter in the universe's story. First, these laws were applied to the dark energy dominating universe, and the results we got were shocking. First of all, the galaxies that are not gravitationally bound to us will eventually disappear one by one. They will keep moving farther and farther away from us, and the space between them will keep expanding faster and faster. And this led us to a conclusion that is even more disturbing. This means that a time will come when, due to the expansion of space, a photon traveling from our galaxy to another galaxy or from that galaxy to ours will reach a certain distance where it will never be able to reach us or them. It will just keep traveling, keep running in the fabric of this ever-expanding universe, but it will never be able to reach anywhere because space will be expanding at a speed much faster than the speed of that photon. It's like he's running on a treadmill, but he won't be able to reach anywhere. If this thing can trap a photon like this, then we humans aren't even at 1/10 the speed of light. But just think for a moment, if we set out on an intergalactic journey and got trapped in such an expanding space trap, we would end up wandering there for eternity. We would never be able to reach the other side, nor would we ever be able to return home. This is nothing less than a terrifying nightmare. At that time, this space would seem no less than a black hole to you. The only difference is that here you would be able to struggle, you would get some time to stay alive, but you would never be able to get out of here. If we talk about the present, the radius of our observable universe is about 46 billion light years, and that magical distance, meaning the reachable limit, is only 18 billion light years. You might be really shocked to hear that already 94% of the observable universe is out of our reach, and only 6% of the observable universe is within our reach. If there's a galaxy at the edge of that, and if we set out to explore it today, we could get there, but we'd have to travel at the speed of light, right? That means that every second, about 2,060,000 stars are moving out of our reach. The light that left that star this second will eventually reach us one day. But the light that leaves that star at the edge in the next second will never be able to reach us. This also feels scary to us. It's creepy, it's disturbing. A different kind of thoughts start coming to mind. But we can also think about this in a positive way, that the universe wants to tell us that every second of life is very precious. If we want to travel between galaxies, if we want to go beyond our local group, then we have very little time. Every second, 60,000 stars are disappearing from our reach, places where we might be able to go. The more we delay, the more opportunities we will miss. There are about 2 trillion galaxies in the observable universe, and out of those, 94% have already moved beyond our reach. Only 6% are left. Even that number is continuously decreasing. Another way to look at this is that no matter how big our universe is, only a small part of it, the observable universe, is available to us, which we can see and observe, and out of that, we can only reach 6% of it. So what's the use of such a universe where we can't even go? This raises a lot of questions in our minds. Are these limitations being set by the universe itself, or is there someone else stopping us from exploring this universe? And what if we don't develop intergalactic travel soon? The whole of human civilization will remain confined to our local group. The whole universe will slip out of its hands like sand, and all the other galaxies will slowly disappear from sight. A sky without stars will look completely dark, scary, and strange. Many questions come to mind. Sometimes you wonder why there is a speed of light limit. Can't we do anything about it? Will we always be trapped like this? Yes, of course, these questions don't really matter to us because this is a long process of billions of years. We won't be able to see any of it. But it's these very questions that have brought our science this far? What are your questions about this universe, and can we stop the universe from becoming this lonely? Do let us know your opinion in the comment section. I hope you liked today's video. If you enjoyed the video, please like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and enable the bell notification. Friends, we will meet again soon with another new informative video. Until then, stay curious, be happy, and goodbye.